All right, here we go. So based on that information, we know that, right, the precision is 0.1 centimeter and the uncertainty is 0.5 centimeters. Yeah, it has to be a 1. So what are we at here? 1, 2, 3, 4, 5. Okay, so half a mark for each. So here the precision is 0.01 of a centimeter, right? It's the second decimal. That's the limitation of this device. And the uncertainty is 0.005. No, wait. What happened? My bad. I got this one wrong. Right? 0.1, it would be 0.05. My bad. So you can put a check mark on it after all. Okay. The weight here, 3 decimals. So you go 1, 2, and then the third decimal gets the 1 there. And I don't know if you've noticed, right? If there are 2 zeros, if you split this in half, you end up with 3 zeros and a 5, right? Next, this pressure gauge here. So you go by the markings, right? So it's 1, 2, 3, 4, 5. 5 spaces between 10 and 20. So that'd be 2 psi is my precision. Right? And the uncertainty therefore is 1 psi. Pounds per square inch. What do you measure psi in? Is that air and your tires, right? It's psi. So next we have this, and you can tell, right? This would be 30, and then 40, and then 50. So you're going up by 10 every time. So your precision here is 10 milliliters, and therefore your uncertainty is 5 milliliters. So 5 marks if you got them all right. 1 mark basically per question. Half a mark for each. Okay. Next, measurement and uncertainty. So you really quickly want to do this. Right? You figure out the uncertainty, then you write down 23.5 inches plus or minus 0.5 of an inch. So you get a full mark if you write this out like that. Okay. Next, you have precision here. You could say quarter of a foot, or you could say 0.2. Sorry, I gotta be careful here. If you turn this into a decimal, right? Then based on that decimal, your precision would be 0.01 of a foot. So either one of these is acceptable. Therefore, my uncertainty, if you go half of quarter foot, is 1/8 of a foot. Or you split this in half, 0.005 of a foot. And now is your measurement, right? How about I just stick with decimal here? And so if this is what I'm after, you get a full mark. Oh, you can't see that because I'm off grid there. So that is for the full mark, you need to have the measurement and the uncertainty that goes with it. Here your precision is 1, 2, 3 decimals. So 0.001 of a millimeter. Uncertainty, yeah. You technically don't. I would strongly recommend you do. Because that's when every time you do shortcuts, you run the risk of a greater risk of making a mistake. And this one here, the precision is 0.1 of a second. Uncertainty is 0.05 of a second. So this would be 4 minutes, 23.5 seconds, plus or minus 0.05 of a second. Yep. You converted the minutes, so okay, and then you added a 23 to it? Sure. I'm fine with that. And then 0.01 of a meter is my precision. My uncertainty is half of that. And so it's 350.00 meters plus or minus 0.005 of a meter. About the 0, 0, 0. Yeah. I would say it's okay. Today, you're not wrong, but I would say in this unit, try to keep all of that in there, right? Because it's telling us what that instrument, the precision of the instrument. So try to keep it in there, but I'm okay if you didn't. So 10 marks for this page. Next page. Which beaker is more precise? Explain, show work to earn marks. So if you just said, you know, you rolled the dice or you just close your eyes and see this one, that is not good enough, right? So basically, you want to go precision, precision, precision. That would be sort of showing your work here. So you can tell that this goes up by 100 mLs, right? 304, right? And this one goes up by, ooh, that's hard to see. 20, yeah, because this would be 60. So this goes up by 20 at a time. So the precision of this beaker is 20 milliliters, and the precision of this one is 50. Yeah. Took me a while to find this one, but this one really shows whether or not you know what's happening, right? And so this is the more precise, right? Beaker B, comma, since it has the smallest increment, right? Has the smallest increment, or you could say has the smallest precision. That's fine. This would be 1 mark for this, and then 1 mark for obviously identifying the correct beaker. Okay, so if you identified the correct beaker, if you said this one, B, you get 1 mark, right? But to get 2 marks, you would have to show how you got there. Okay. Next, a welder is welding 3 pieces together to strengthen the bottom of a trailer. He buys all 3 pieces online and knows that the measures are as follows. Determine the precision and uncertainty for each piece. Sure, we'll do that. Okay. So this is 0.1 of a foot, right? And the uncertainty therefore is this. Then the next piece is 2.75 of a foot. The precision there would be 0.01 of a foot. And there's a 0.005 of a foot is my uncertainty. And that last piece, the 4-footer, is 1 foot. And so the uncertainty is 0.1 of a foot. 0.5 of a foot. So you get 3 marks if you have them all listed like that with units and everything. Calculate the combined length of pieces, including the uncertainty. So I will allow you to just use this and just add it all up. You don't have to show that all again. So this would be 9.95 feet. Like if you add up, because you're welding them together, the assumption is you're adding, right? And then plus or minus, if you add up all these, you get 0.555 feet. So you get 1 mark for the correct measurement and 1 mark for the correct combined uncertainty. Now, if you messed up in A, of course, I wouldn't take away again here, okay? If I see that you added the uncertainties, you get the marks, okay? That's just how it goes. That's just how it goes. And I think that's fair because you're showing me you understand what's happening in spite of the mistake you made. Okay, Calculate the combined maximum and minimum lengths of these pieces. So to get your max, you have to take the 995 plus the uncertainty. To get your min, you need to take your measurement. Again, whatever you got up here, if you're doing the steps, you get the marks, okay? So if you're adding, it gets you 10.505. And if you're subtracting, 9.395 of a foot, okay? So one for each. So when you're welding them all together, it could be 9.395 or it could be 10.505 based on our reasoning behind precision and uncertainty. If you ever end up getting a job where you use this, email me. You know, it's like, hey, I actually do this kind of stuff. If you're working with engines, if you take apart engines, you most definitely will look into this. We're going to talk about tolerance after this. And there's a lot of moving pieces that just they fit perfectly, but there's not a whole lot of wiggle room, right? It has to be, can't be too big, can't be too small. A carpenter is installing a 2.4 meter piece of trim. I didn't tell you what trim is, but he cuts off, that's the important thing, cuts off 0.5 meter to fit. Calculate the length of the trim after being cut, including its uncertainty. Trim is, your houses have it like the trim is like the moldings at the bottom, or some have it like on the ceiling, like where the wall meets the ceiling. And yours is usually out of wood, and some have trim around the doors as well. They have like a profile to them. That's trim. So anyways, we go 2.4 meters. I told you it's okay to do this. Right? Just write them down like that, and we will subtract because we're cutting off. Right? We're cutting off. So that precision there is 0.1 as well. Uncertainty is 0.05. So they both have the same uncertainty. Good. When you subtract by cutting off, you get this. Plus or minus, you forget about the precision. You just focus on this. That's 1. That's 1.9 plus or minus 0.1 of a meter. So I would give you 1 mark for showing this work and 1 mark for the correct final answer. 0.10, that's fine. Yeah, that's fine. How about this one? This is where I'm really curious to see what you did here. If you measure 50 pieces of wood and they measure this, what would be the combined uncertainty? Just the uncertainty. So you're basically adding up 50 of the uncertainty. So it's really just 50 times 0.01 of a centimeter, right? You would be adding 50 uncertainties together, and that gives you 0.50 or 0.5, either one, centimeters. That is the combined uncertainty if you were to add them all together. Okay. So this page is worth 2, 4, 7, 8, 9, 10, 11, 12. Backside is worth 12. So 10 and 12 out of 22. Whatever your mark is out of 22, make sure your name and last name is on there. Pass it forward and get your notes out.